So in this video, we're going to take a look at traffic movement through a network, as well as how network design can affect traffic by creating the need for more traffic or less traffic, and the distance traffic has to travel. So what we're going to do is start by looking at our topology here. So I'll switch over and we'll go to the bigger view. And you can see here that we have a basic partial mesh topology. So we have two switches at the distribution level connected to the core. We have servers here for web and DNS. We have PC sales server for HR, and then we have, of course, PC spread out through all of our switches. So the instructions for the packet tracer tell us that we should ping to the different servers. So this is the address of the HR server. This is the address of the sales server. Down here, 10.2, and packet tracer always drops that first packet. I don't ever understand why. And then this is the address for the web server. So you can see we can get to all three from this HRPC. So what we're going to do is we're going to take a look here at the way the traffic flows through the network. So we go ahead and turn on the auto capture. We watch the packet travel from the HRPC to the switch to the distribution router. The router determines which network that packet needs to go to, which it determines that it's on that particular switch, pushes it through, and then the switch pushes that information out to the HR server. The HR server go ahead and return and sends that back to the switch, back to the router, back to the main switch for the computer that sent it, and then back to the PC. And it's cool with it. Alright, so we'll go ahead and clear this. Alright, so one of the things that kind of creates a problem here, let's go back to a different view, that we could do to make this a much more efficient network is, depending on design, we could actually create a server farm. So we could take and move these random PCs that are connected in random switches and move them around in the data center so that we have all of our servers plugged into this one switch on the same network, or even on different networks, just as long as they're all plugged in the same switch. The advantage to that is we reduce the amount of hops that a packet has to take to go from point A to point B, thus reducing our latency, making things faster, making our network flow better. Because you see in this, for a packet from HR, that ping packet to go from here to the server for sales, it has to go up through this switch, up through this switch, or up through the switch, up through the router, through the switch, to the server, and then back. And if we want to get to the web server, we have to go up the switch, up the distribution, up to the core switch, up to the servers, and then we have our web and our DNS. So if we were to move these over here, all of our traffic for servers would be going to this one location. It wouldn't be spread out over all of our different switches, causing our switches to have to work. And then it also eases up on administration for us, because then we can set that this is the only switch that has servers in it, so it's easier to do access control lists, it's easier to do VLANs, it's easier to, we can set this so that if anybody plugs anything in that's not one of our specific servers, the switch goes down, switch port security. We can do a lot of things like that this creates a lot more headaches. So again, this goes back to design. We need to think through network design so that we have, all of our major components centralized in that we have a server farm, but then we also need to have some redundancy. So if we're going to set all of our business servers on one switch, we need to have two switches, and we need to have those backed up, and we need to have another switch spanning tree two network cards so that when this switch goes down, because it will, this switch can pick up the load and we don't have any downtime until we can come in and fix it. So that's a brief overview of how network design, server traffic, and how network traffic can travel through a network, and how our server design affects that traffic.